Today we'll be doing an intro to oceans and specifically talking about ocean currents. The first thing we'll look at is things that affect ocean currents. Now there's a checklist here of things that affect ocean currents and we'll be focusing on the top three. So we'll be focusing on wind, we'll be focusing on the Coriolis effect, which comes from the rotation of the Earth, and we'll be focusing on water temperature. But salinity, the amount of salt in the water, as well as the shape of the seafloor have huge effects on ocean currents. Now there's two types of currents. There's surface currents and there's deep currents. Surface currents actually only affect the top layer of the ocean, and if you see on the screen, they only actually move about 10% of the water in the ocean. So that's a small amount of the moving water that is affected by surface currents. Now there's two prime things that affect surface currents. The first is wind, and you see this every day, whether you're on the Barwon River, whether you're by the ocean, or whether you're on a lake. Depending on the direction of wind, the surface, the very top layer, will move with it. The second thing, and probably the bigger thing, is the Coriolis effect, or the Coriolis force. Now the Earth is constantly spinning, and I'm going to send you to another video that explains this Coriolis force. But the Earth is constantly spinning, but because the center of the Earth around the equator is fat, is a much larger, longer distance, while the poles are a much smaller distance, basically what happens is, as things are moving on the Earth, the difference in distance they are traveling causes both wind and water to skew in one direction or the other away from the equator. Now, you can see in this second point, under the Coriolis force, if you are north of the equator, the spinning occurs in a clockwise position. If you are south of the equator, it happens in a counterclockwise direction. And if you watch views from space of a hurricane spinning on the ocean, hurricanes north of the equator spin in the opposite direction to hurricanes south of the equator because of this Coriolis force. Now the Coriolis force, or the Coriolis effect, also helps create ocean gyres. Now ocean gyres we're going to look at in a little more depth another day, but these gyres are places in the ocean where the Coriolis effect, the spinning of the surface water, essentially creates a vortex. And there are 5 major gyres in the world, and you can see them on this image. You can see that these gyres, when they're north of the equator, spin in a clockwise rotation, and when they're south, spin in a counterclockwise direction or counterclockwise rotation. Now, when you were reading the article about the ducks a little while ago, the ducks, when they ended up in this North Pacific gyre, some of them eventually got spit out and headed north through the Bering Sea. But others, if you looked into the middle of the gyre, would still be stuck in this big patch of garbage that is found in the middle of the North Pacific gyre. And again, we'll look at this in more depth later, but these gyres have huge garbage patches in them. The North Pacific gyre, they say the garbage patch is roughly the same size as the state of Texas, which is the second largest state in the US. So there's a huge amount of garbage that gets sucked into these North Pacific, or into the different gyres, but specifically into the center of this North Pacific gyre, and just gets stuck there. Now the second type of current is the deep current, and it moves the majority of the water that is moving around the ocean. It actually moves 90% of the water in the ocean. And the deep current is part of something called the thermoline circulation, which is more commonly known as the global conveyor belt in the ocean. And it's driven by both temperature and salinity, though we're going to focus more on temperature today. Essentially, the warm water in this conveyor belt stays closer to the surface, and the cold water drops down into the depths. In fact, in places, you'll see it go underneath, so the warm water current will pass over top of the cold water current that's going underneath. And these currents basically act as a mixer for the world's oceans. It means that water is moving around. It's not creating dead zones in one area. It's moving life from one place to another. It's moving nutrients from one place to another. It keeps the global ocean fresh. Now you can see it here. In general, the warm water currents are found closer to the equator, and they cool down as they get further from the equator. Now, obviously, you can see that is not necessarily the case, because we've got one long line of warm water that actually travels fairly close to Antarctica. But if you look at this overall global conveyor belt, I want you to look up here at the top left, where there are huge heat releases into the atmosphere. So those huge heat releases into the atmosphere are very, very important, and becoming more important as we talk global climate change and global warming. So make note of these two release areas in the north, because in the future, the change in the water up north could have a huge effect on where this overall global conveyor belt runs. Now, the other thing I want to talk about is the hot and cold as far as density, but also just these things called upwells and downwells. Now, upwells and downwells are caused by a few different things, but essentially it's caused by the direction of wind and the movement of water because of the Coriolis effect. Now, it's key to look at these upwells and downwells, because the upwells and downwells can have a huge effect on the health of the ocean, and actually a huge effect on the health of the planet, because our ocean is one of the largest carbon sinks that we have. So we talk about trees taking in carbon dioxide and breathing out oxygen. The oceans actually take in carbon dioxide and push them down, pushes the carbon dioxide down into the depths of the ocean and holds onto it, and therefore decreases the amount of greenhouse gases that are in our atmosphere. Now, how does it do that? In the downwells, essentially the warm water on the surface grabs carbon dioxide, and as it sinks, colder water actually holds on to carbon dioxide better than warm water. So as it sinks, it holds on to that carbon dioxide and keeps sucking more in from the air at the surface, and acts as what's called a solubility sink. So the downwelling is very important for the action of the ocean being one of the globe's carbon sinks. The upwells, on the other hand, the upwells play a huge part in creating fertility in the ocean. So when the water moves up along the seabed and to the surface and then sweeps away, as it comes along the seabed, it picks up all sorts of nutrients in the bottom and disperses them all into the top layer. And that dispersion of nutrients allows the plankton to eat, and when the plankton eat, and when they're close to the sun, because they need energy from the sun to grow, when they eat and suck in this this energy from the sun, they grow rapidly. And this upwell area is a huge source of food for fish. And so where the upwelling occurs around the globe, you'll find extremely fertile fishing grounds. In Canada, for instance, there's a huge upwelling just off Newfoundland and Labrador called the Grand Banks. And there was rumors, I guess there's historical accounts that when Europeans first came to the Grand Banks, that they could almost walk on the fish. They were so thick in the area where this upwelling was occurring. This last image is just looking at the idea of a solubility pump, the idea of CO2 being captured by the ocean and taken down into the depths and held by the ocean as a carbon sink. So if you think of the idea that the colder the ocean is, the more carbon dioxide it can hold. When people are talking about the warming of the world's oceans and the warming of the world in general, this creates a problem for this idea of a solubility pump, because if cold water holds more carbon dioxide and the oceans are warming, that means overall the oceans are going to hold less carbon dioxide, which means there are more greenhouse gases being released into the atmosphere, not even because of increased production, just because of the inability for the Earth to hold them any longer. So that concludes our discussion about the basics of ocean currents.